Okay, YouTube, today we'll be covering another crazy integral, kind of. So, this time we are covering the integral from negative infinity to infinity of e to the negative x squared times cosine of 1 plus x squared dx. So, before we start integrating this, we have to notice that this kind of looks a bit complex. And we'll have to kind of break it down. So we observed that there's an e to the negative x squared term here. And you may recall from one of my previous videos, that Gaussian integral video, that e to the negative x squared, that integral is equal to square root of pi. So if you just do some simple calculus, you can also determine that e to the negative z x squared dx is equal to the square root of pi over z. Okay. So the reasoning for this is a simple u substitution. So we could set u squared equal to z x squared if we're solving for this integral. So u is equal to square root of z x is outside the square root, sorry. So then du would be square root of z dx. So dx would be du over square root z. So basically, this is the same thing as saying negative infinity, infinity. Bounds don't change because you're just multiplying by a positive constant. E to the negative u squared, then that's times 1 over z times du. That's just this. So now that we have our background, we can notice that this has huge implications for this problem. We will find out later why. Because z, for any complex number z, so I forgot to mention that z is an arbitrary complex number, and it's a constant. So z's an arbitrary complex number, a constant. So any complex number we plug in here, z just appears in the bottom of the fraction in the square root. So we'll find out why this has implications. Now I'm going to erase this to make room for the problem. So if you remember from, I don't know, high school math class probably, you may remember cosine of x is equal to 1/2 times e to the ix plus e to the negative ix. Simple identity. So if you say that cosine of, so we could plug anything into x. So you could say cosine of f of x is equal to 1/2 e to the I f of x plus 1/2 e to the negative I f of x. So if you set f of x equal to 1 plus x squared, which is what we have here, then that would mean cosine of 1 plus x squared is equal to 1/2 e to the I times 1 plus x squared plus e to the negative I times 1 plus x squared. So we can plug this into the integral. So let me just get rid of this, put this on top. So this is equal to the infinity, negative infinity, e to the negative x squared times 1/2 e to the I 1 plus x squared plus e to the negative I 1 plus x squared dx. And we can start seeing this integral taking form. We can now start applying that thing that we covered in the earlier with the arbitrary complex numbers. We can't use that formula quite yet because we have to kind of expand this out a little bit. So first of all, let's separate these two terms. So we have negative infinity e to the negative x squared. Let's take out 1/2 of times e to the I plus ix squared. Then dx plus 1/2 integral infinity negative infinity of e to the negative x squared times e to the negative I plus minus I x squared dx. So now we can just factor out e to the I because that's a constant for this left side, and we factor out e to the negative I on this side. So we have 1/2 e to the I times infinity negative infinity of e to the, now we can kind of factor this out. So we have x, we could factor x squared out, or negative x squared. So we have negative x squared out here. Then we have 1 minus I dx. We have our arbitrary constant number here, so z1 equals 1 minus I. That's plus 1/2 e to the negative I. We're factoring this term out now. Infinity, negative infinity of e to the negative x squared power 1 plus I dx. Okay, so now let me just erase these top terms. If you want to go back to some of the work, you can just go back if you want in the video. But I'm going to keep going. And our arbitrary z, number 2, is 1 plus I. That was not a very good I. 1 plus I. Okay, now let's continue. So let me draw this on the top. 1/2 e to the I, infinity, negative infinity, e to the negative x squared. You know what? Instead of just writing everything out, I'm going to evaluate each individual one right now. So that's 1 minus I dx. So this is going to be equal to, well, that's 1/2 e to the I. This is going to be square root of pi over what we have in here, 1 minus I. So plus 1/2 e to the negative I e to the negative x squared 1 plus I dx. That's equal to 1/2 e to the negative I square root of pi over 1 plus I. Okay, now I can get rid of this. So now we have, our answer should be 1/2 e to the I times square root of pi over 1 minus I plus 1/2 e to the negative I square root pi over 1 plus I. So the thing is, when we started this problem out, we had all real numbers. So it's a bit weird that this solution generated complex numbers. So this last part of the video, I'm going to try to resolve that, because we shouldn't be getting complex numbers or i's inside our final answer. And we don't have to. It just requires a bit of algebra and pre-calculus. So if you may remember from your Algebra 1 class or pre-calc class, this is a complex number with magnitude square root 2, because the modulus of 1 minus I is square root 2, because this is the same thing as saying square root of 1 squared plus negative 1 squared. Square root of 1 squared plus negative 1 squared. That's that's square root 2. So same thing for here, where we have a modulus of square root 2. So we can write 1 minus I and 1 plus I in terms of e to the I theta, but we have to know what angle theta this complex number corresponds to. So let's quickly draw a unit circle to determine this Yeah, you could probably figure it out without a unit circle, but I like to do it a bit geometrically. So this circle is radius square root 2. This is complex. This is reals. Okay, so 1 minus I. So 1 minus I is probably here, negative I, 1. So theta here. So this is in the fourth quadrant. That's inverse tangent of negative 1 because it's negative 1 in the y direction over 1. So our argument or inverse tangent is going to be negative 45 degrees, or in this case, negative pi over 4. That's argument 1. So this one. Now argument 2 is going to be inverse tangent of, so it's 1 plus I here. So this time it's going to be theta 2. It's going to be also 1 in this direction, I in this direction, so 1 over 1. I drew a sloppy circle. It could look better, but whatever. So that's pi over 4. So we now have 1/2 e to the I square root of pi. Now, it's not only expressed as e to the I theta, but r e to the I theta. So we know our r is square root of 2. So over square root of 2 e to the negative I pi over 4 plus 1/2 e to the negative I square root pi over square root 2 e I pi over 4. So now we can simplify this further by multiplying out or taking this e to the negative I pi over 4 out of the square root. So I'm going to erase all of this. So I'm going to bring this here. So this is equal to 1/2 e to the I times square root of pi times 2 to the negative 1/4 times e to the positive I pi over 8 power, because when you have this in the denominator, you have e to the negative I pi over 4 in the denominator. If you brought it up to the numerator, it would just take out the negative sign, so it would be e to the I pi over 4 positive, and then the square root just halves anything in the power, so that's why we have pi over 8 positive. So same thing here, plus 1/2 e to the negative I square root pi 2 to the negative 1/4 times e to the negative I pi over 8, because remember, you're halving and then taking the negative since it's in the denominator. So that's equal to 1/2 e to the I times 1 plus pi over 8 times square root pi times 2 to the negative 1/4 plus 1/2 e to the negative I times 1 plus pi over 8 times square root pi times 2 to the negative 1/4 power. So we can group this. You may kind of notice something here, because remember, cosine of x is equal to e to the ix plus e to the negative ix times over 2. So this case, our x is going to be 1 plus pi over 8, because we have a 1 plus pi over 8 on both sides. So this is going to be equal to cosine of 1 plus pi over 8 multiplied by square root pi times 2 to the negative 1/4, or square root pi 2 to the negative 1/4 this side times cosine of 1 plus pi over 8. And that is our solution to this really funny integral here. Okay, thank you for watching. See you in the next video.